So what are render samples, and why are they worth optimizing? So a sample is a calculated color for a pixel, based on shaders and lights. But why are there so many samples? Why do I have to go up to 2048 samples? Firstly, noise. Probably why you came here. But more obviously, 3D mesh edges don't fully align with the grid-like pixels on your screen, right? To accurately display non-straight lines, you have to do something different. So each sample is slightly different. Slightly different in where the ray starts and what direction it goes. The slightly different samples, averaged out, make a smoother and more accurate image. You could just add more samples to your render, and eventually it goes away, but that takes more time, doesn't it? For this video, as part of my Optimization in Blender series, I'm offering a better way to understand what is going on with these samples, why there's noise, how you can make samples more consistent. This results in needing less samples and therefore faster renders. Why you're here. So how do we get rid of all this noise? Back to my definition, based on shaders and lights. Let's break down shaders first. The first one is simply to just have the shader be swapped out or transition to less complex ones. For instance, you can have it be that maybe you have a really waxy character and you want to really emphasize that subsurface scattering. Or for the close-up shots, you want that, but maybe for the farther away shots, you can get away with a more diffuse version or just a less significant subsurface scattering. And you can actually do that in the shader. I was actually looking for this right before recording this, is in the camera data. And so with this, you can use a map range. So you can start to see this gradient here with the Z depth. And so if I move this around, you can see it gets darker and brighter. And this is a great way of being able to factor in the distance. Hey, if this object is close, factor in subsurface scattering more. And then when it's farther away, you can factor it in less, right? So that is a great way of being able to simplify your shaders for different distances. So that's one way of going about it. Let me also add that randomness isn't a bad thing. The randomness itself is not the problem. So if I wanted to zoom in on this, for instance, you can see there's some fireflies from this, but that's mostly just it being noisy because it hasn't sampled it enough. If I went to 1024, you can see it's clearing up a lot and it's pretty much there. Important thing is that these shaders are assuming that you're using multiple samples. Because for a computer, having each sample have a random direction for the reflection or refraction or volume is a lot more efficient for the computer than to try to have one perfect sample where it tries to take all the possible light directions, right? In our case, we don't want to abolish randomness, but that we want to kind of pull back the randomness when it ends up slowing down the renders too much because we need way more samples than we want to, or just the shader or lights otherwise are just problematic. The other one is there's a hacky node that I found really useful, and it's the light path node, which you may have heard of from other videos potentially, but maybe not in this context. So for context, this is left Suzanne is just the base principled shader. I'm going to make it metallic for this example. So otherwise in these cases, it's pretty much the same, but this right one has some optimizations added in. You can kind of see that some of these otherwise noisy areas are actually much clearer. And so let me break down the shader. Again, it's the same principled shader, but it's mixing in a diffuse shader, and it's using this light path node. Now, I don't know if you know this fun little tip. You can use Control H to collapse nodes to just the sockets that are being used. So for this one, for instance, if I collapse it, it's just the used sockets, the linked sockets, I should say. But the light path node, what it does is it takes the rays from the path tracing that's being done by cycles or the rays that are used in Eevee and brings that information to the shader. And so I can be able to say of like, hey, is this the ray that is coming directly from the camera? So no indirect lighting has been done, but it's just the ray directly from the camera. Is this a shadow ray? So is that the ray that as it's going towards a light from a shadow, it runs into this object? How should the shadow treat this object? And there's diffuse, glossy, and ray depth. I will note that not all of these are supported by Eevee. As of 5.0.1, you can just load the manual. I sure hope most people are aware of the manual. So there's some of these that are cycles only. I will just note that It doesn't mean that Eevee doesn't support them like it should support them. It's more just that with how Eevee renders, some of this info is just irrelevant to Eevee. It just doesn't need it. Eevee and cycles support different things when it comes to this light path node. But the one that we're using here is the ray depth. Now, depth is just referring to the number of bounces this ray has gone. If the rays just come from the camera, it's at depth 0. And after a bounce, it's at depth 1. And another bounce, depth 2, and so on. So this is just saying of, hey, after one bounce, turn the factor to 1 and treat it like a diffuse. Now, it doesn't seem really obvious here what the difference is. Let me add a visualization where I cut this color out. The green is the indirect lighting. As you can see, it's all these kind of like reflections of reflections here. It's not even in that reflection very much. If I turned it down to 0, then any indirect lighting becomes the green, which is really funny to see. We do want those reflections in the reflection. So that's why I turned it back up to 1, because I want a little bit of that, because it does make a big difference. But in these other areas, it's not so obvious. Especially like this little arc here is missing here. Now, you're probably saying like, well, this is just not true glossy because you're hacking it to be less glossy. Yeah. You probably may notice in your projects of like, oh, this glossy surface is really noisy, but I don't really need all these little mini reflections. Maybe I can just simplify that. This is how you do that. Introducing this hackery, this not simplicity, but replacing parts of the shader with simpler shaders to make this more consistent. Because the light path basically allows you to break down your shader in pieces based on what the rays are doing. With that, let's get to the glass. So with glass, it's a lot harder to get close in terms of results because glass is naturally very complicated, and in any hacking and changing of that shader often loses features of it. Glass on the left is just a perfect transmission glass shader, and it also has caustics on. And the right one, this one has caustics off. I'll actually turn it back on just to be able to show how similar it gets. I'm using the ray depth again, but I've set it to 3. That's because of, if I set it to 1, you can see it's basically just frosted at that point. And we don't really want that. We still want to be able to have a mostly smooth glass. I mean, this is 0.01, so it's still blurry on this glass, but adding a couple extra bounces in there allows a closer resemblance while only saving us fireflies and issues on the most indirect parts of the render. This is just saying of like, if the ray depth is less than 3, use the principled glass, otherwise do the translucent, which is that diffuse transmission. Now we can also try it with the other one, which you can see that definitely added more translucency in this inner part. But in this case, it's saying of, if it's a camera ray or a transmission ray, take the maximum, which would be, it's just 0 or 1. There's no in between. Take it as 1 to here. If neither of them are true, then it's a 0. So it's these little changes of breaking apart the shader and simplifying aspects of it so it's less noisy. Yeah, and I think I would probably say this one is probably better. And of course, you can always turn off the caustics. In an artistic sense, you probably don't need all the realism. You could probably get away with less complicated shaders for everything. So instead of having the complications of glass for every aspect of the material, only use glass for the initial part of it, and then the rest just be this translucency. And to further prove the power of optimizing shaders for improving samples, I decided to affiliate with Smouse's Shaders Plus add-on. So I'm going to provide an affiliate link below, which will work across all of Smouse's products. But I'm going to demonstrate of how Shaders Plus works in this example. All right, so I have the add-on installed, so I'm going to enable it. Back to our glass scene, I'm going to add, let's see, so right-click menu, there it is. The principal presets, and here let's go to the complex one just for good measure. Look at those bright caustics. And again, this has the caustics turned off, so this is just purely done by the shader. And so I'll turn down the caustic strength. Okay, so there's an energy conservation setting. Yeah, I love these little caustics in the corners and all that. Looks like it can kind of shimmer a little bit. There's also dispersion. Oh, you can turn it above 1. Oh, let's see. Oh, look at that. Look how colorful that is. Okay, so you can decide if default shadows or caustics taking priority. The caustics as high as you want. I love how stylistically adaptive it is. Because usually with shaders, I see it's very photorealistic focused, or, very stylized focus. But this one, you can kind of adapt it to whichever one you need. Tone it down to a more simple caustics. Oh, okay, I see. So it's kind of more of just in these little specific areas. Ooh, I like that. I've bought this add-on for a long time, but I never actually got around to using it. When I reached out to Smash for this affiliate link, this is me trying it. So this isn't a bit. This is me trying it out. Add extra things of dispersion and thin film. I really like this. And of course, there's all different types of options. So there's kind of looks like a plus version of existing shaders, as well as some other preset based ones, which is really nice. What is that? Huh. Cute. And this is a great example of being able to optimize the shader. You can get very likable results with none of the noise. So I'm going to provide an affiliate link below for any of Smouse's products if you're interested. And finally, with the volume. Volumes is the final boss of this, because you can see, like with this example of just the default volume, it is so noisy. And with these, I am adding a bunch of bounces, because with volumes, you do want the extra lighting and bounces. Of course, if you turn the bounces down, that takes a lot of noise, because you're basically just cutting out the indirect lighting. We'll get into the render settings aspect of this in the final part, but just know that that's relevant too. So I'm keeping the bounces high for these examples. I found some fun ways of cleaning this up dramatically, and that's using an emission shader. So it's saying of like, is it a camera ray? So it's the ray directly from the camera, then use a volume. And so most of this that you're seeing is just the volume, but everything else is an emission shader. So this reflection is just an emission volume. It's so noisy. And over here, it's way, way cleaner. It's not perfect or free from noise. Like obviously this is very noisy, but that is far easier to manage than this. And again, this is about making your samples more manageable. So when you need to do less samples and you need to save the time by doing less samples, you can get still something consistent enough that denoising is very effective. Now we have the shaders optimized, let's get into lights. So with the lights, we have this example scene of a box with a window. That's literally all it is a box with a window. So you can see with this, the denoising's on. If I turn it off, look how splotchy that is. There's just lots of little black spots and white spots, because they can't decide if it's being seen by the bright world outside or not. So how do we do this with world lighting? So you could just add a light to the window, and this is literally just blocking out the light. So it's almost as if that the world shader isn't on at all. Like it's visible from some of this light leaking and whatnot, but it's not really affecting the interior lighting at all. So the ways that we can optimize here is, one is with the multiple importance. This is actually one of the cases where turning it off actually resulted in a better result. Now this is still super noisy, but it is brighter. Now by default, multiple importance is on for just about all lamps and materials from my understanding. And in most cases you do want it on. Basically it just samples lights more directly, and it's assuming that that light should be sampled in most cases, if you just sample it directly. In most cases you should just have it on, but especially for less significant lights and other things, sometimes it's better to have it off. But in this case, we want the world lighting outside, not necessarily this light. And that can be solved with the portal toggle. Now, if we turn this on, it's telling cycles of, hey, all you surfaces, if you sample me, don't sample my light properties, sample the world shader. And so it's getting this way cleaner result. Like, let me toggle it on and off. Look at that. That is way cleaner, way more consistent. Look at that. Way cleaner. Okay. Portals are a great way of simplifying cycles work by making it clear of like, hey, this is world lighting. So we're going to turn off the world lighting and add the more problematic lights. And now the problem with these is that these are very, very small lights. And because of that, these surfaces can't always hit it, because there's these little spots of like, well, I don't think I saw either of these lights, so I'm just going to stay dark. And then someone's like, well, I could see the red one, but not the blue one. Or I could see the blue one, but not the red one. It's just so messy. Now, in general, small lights are the problem with it. And so to solve this, the idea is to have physically larger lights. So I do this, and these lights are normalized so they get dimmer as they get wider. But the idea is that by making these bigger, the sampling is far more consistent because the lights are bigger and more likely to be hit by the rays. Of course, this dramatically changes the lighting. And that's one of the problems with lighting that you're trying to solve. You're trying to make sure these lights are sampled consistently, but also that they still have the precision that you want them to have. Something I'll also note is that you can set the bounces or the indirect lighting of these lights. So I'm holding down Alt, so that way I can set them both at once. So it's that with 0, there's no indirect lighting. You'll be able to adjust these bounces in a more global way in the render settings, which we'll get to in the last part, but just know you can do it per light. Now, if you need to have small lights and they're overlapping and contributing to the same area, then I'd recommend this trick. Now, I learned this as part of a Blender conference talk that talked about this. So I'm going to run a render of this, do it at 512. And so this talk talked about of how
when you have multiple lights, they kind of fight for the pixel and it gets very noisy. But in a linear workflow, if you group lights together, then render them separately, you get a much cleaner image with less samples. We take first the area lights, all the spotlights around. Then we render just the neon lights, then just the billboards, and then just the windows. Then when you add all of this together, you get a very clean image.
So what they did is they used light groups. Now you can also replicate this with view layers. For the many of you that have watched my view layers video, thank you. So you can have a view layer set up where one view layer is just the cool lights and one is just the warm lights in this example. But in this case, I turned on denoising data for what I'll use in the compositor, but you create 2 light groups in the view layer properties first, and then you get your 2 different lights and set them into the group that you want them to be in. So you could do it with view layers or light groups. That's up to you. So you notice with this, like the denoising is all right. It's kind of splotchy around the edges and especially around the light itself. But so let's compare. So there's this area, and then what I did was I denoised the different light groups. So there's this warm, for instance, turned out really noisy still. And I denoised it with the denoising data, so the denoising albedo and normal. Is it albedo? Albedo? Albedo. Let me know in the comments which one's the correct answer. So denoise that, and then this one denoised as well for the cool lighting. And let me first show you the difference. So I'm just subtracting one from the other. It's a little bit more splotchy, some of these areas, and especially around here, it's much more splotchy. So let's see. Okay, so this is the out of the box denoising, and here is the other denoising. Look how clean that was. You see that? I removed some of the splotchiness in these corners too. Now, of course, this is a horribly lit scene, not nearly enough samples. That's part of the point. You can break down your render into different lights when they have these problematic overlappings of the colors and whatnot, and then denoise them, and then add them back together in a much more clean result. So now we've optimized our shaders and lights. Next, we are going to optimize our render settings. This isn't going to be a like perfecting the scene or anything like that. This is just kind of workflow demonstration of the tips and tricks. Okay. But the idea is that we're going to do a lot of renders in the viewport, just so we're not doing full big renders, because we're basically just going to be testing different things. If you have a lower end computer and you don't feel like you can follow along, be sure to use Control B to just render certain specific areas, so it's not rendering the entire thing the whole time. The only time in this workflow where you'll want to see the whole screen, which Control Alt B, is when we get into the light paths step. There's 4 steps: prepping the scene, pretty much optimizing the scene, doing some baseline render settings, so kind of just the basic settings, light paths, which affects the indirect lighting and bounces, and then adjusting the sample count, the noise threshold, and denoising all together. You kind of have to adjust them together for it to work. Not trying to clickbait you with, 4 steps. You seen that YouTube ad from like a year ago?
You can learn 100 songs on the piano
by learning these 4 chords. It still haunts me. Let's optimize our scene. In this scene, there is some really problematic noise. Let me turn off the denoising. The samples are not coming in consistently at all. It's just little specks here and there every once in a while. So some of these have the multiple importance sampling on. Some of these don't actually have it enabled. And so I just set them back on. And just from that, let's go back to this little area. Look at that. That came in immediately. There is no speckle going on. I don't have denoising on. Look at that. That's so clean. Again, we're using lamp objects, so we can take advantage of this multiple importance sampling. So that's the first step in this case. The second thing I noticed is that because the scene is quite large, I'm guessing there's multiple camera animations that you can do or things like that. We're just testing a still in this case. The camera really only sees up to about here. All of this side doesn't really get seen. So just to save some memory usage, I'm just going to hide a couple collections. So you can see the window shaders are actually pretty well optimized, so they're pretty clear lighting in this case. I'm just going to take out the windows for this side, just because the camera is not in front of it, and that'll just simplify some of the lighting. These lights already use Portal, which is great. And then the next thing I'm going to optimize, I'm going to reorganize a little bit, is the shaders. And I want to show you something regarding bump maps. Okay, so the distance and filter width, which is a relatively new setting, is set to 1. Let me show you the normals. You can kind of see, it looks weirdly dark. Let me just show you what happens if I turn the distance down to 0. Look how bright that is. Normals is a big part of the denoising, especially if you do the per pass denoising, which we will do here. I actually am going to adjust these. So the distance down to 0.01, I cannot find for the life of me what the units are. The Blender manual doesn't even say what units they are. If it's anything that I'm getting, it's meters. And this is not, the bump is not a meter long bump, right? So I'm going to turn it down. I mean, you could do it to like 0.03 or whatever, but in general, you should just keep the strength max and turn down the distance. I find that's usually what it is. And then filter width is about how much of the subpixel sampling is going to be done to calculate the normal. 1 seems a bit broad, so I'm going to turn this down a little bit to the default. I'll raise that a little bit. So I'm just going to double check some of these normal maps. Okay, yeah, this one's strength is set to that, way too low. A lot of the shaders are reused, which is good. Then I think a couple of these back here. So this is for wood. I'm trying to avoid artistic choices. I know they could still get mad at me anyway. That's fine. Trying to do some at least very simple optimizations of making it reasonable for some of these shaders. And removing textures when you can from these saves a lot on memory usage too. All right, so that's all of the baseline optimizations done. Next, we're going to set some settings. You could turn off the noise threshold. I'm just going to turn it pretty low. I want to at least see how far the samples go without noise threshold or denoising taking over. So I'll just set it to the 1024 for now. We're going to copy these over to the render settings, but since we're just using the viewport, we'll just be testing in here for now. Turn off denoising, turn off the mid samples and time limit for now. Light tree is for sampling multiple lights. So if there's a lot of lights fighting for the same samples and pixels, this kind of helps with that. In this case, because we have a lot of area lamps here, this is actually a pretty well lit render. I'm going to keep it on. But if you only have like a couple lamps, especially ones that aren't competing with each other, then you could probably turn it off. All right, advanced. This should probably already be set to automatic for you, but since it's an older file, it's probably set to classic. For those who don't know, classic is just random sampling. It's just random. And blue noise is noise that's reorganized, redistributed to be better handled by denoisers. So basically it's saying of like, hey, if you're planning on denoising, this noise will redistribute in a way that it clears up better by denoisers. In most cases, you probably just want to do blue noise, and the automatic it does blue noise, except for when you're like moving around the viewport really quickly or playback, it'll optimize for the first sample quality. In most cases, you can just do automatic. And then the seed, we'll just set to 0. Use animated seed. If you're doing an animation, you can enable this, but we're just doing a still frame today, so it doesn't matter. Once we get into LiPAS more, we'll be adjusting these, but for now, except for the total, I'll bring this back to combined, but I'm going to set these all to 0. And that basically leaves it to just direct lighting. Clamping, I'm going to actually set this back to 0. Basically, if you have any super bright lights and you have a lot of fireflies and clearing up the shaders and optimizing the shaders doesn't do anything, then you can clamp it further. In this case, I'm going to actually try not to. We don't have caustics. I don't think they're even set up for any of the lights anyway, but just to be safe. The pixel filter, it's kind of this hidden, more technical setting, but it's basically that to avoid aliasing and just like ultra jagged edges and things like that. So you want a little bit. In this case, I may turn it down to 1.25. Don't have it all the way to like 1, but just having it maybe a little bit down can help. But I'd say if you're unsure, just leave it at 1.5. And then, performance. So we want to set to GPU in my case. Denoising is set to auto, which will be GPU in this case. Tiling, again, this is set probably by default because it's an old file. And so instead of doing like the per tile rendering, it just renders the entire frame at once. Persistent data, because this is a still, normally I would say just keep it on. I'm paranoid and I'll only render once anyway, so I'm going to turn it off. Save some more memory for me as a recording. Alrighty, and with that, let's start on the light paths. So the light paths and bounces, this is basically just how much indirect lighting per diffuse, glossy, transmission, volume, transparent paths we have. And so we are going to adjust these one by one. We're going to go to this drop down up here. So by these shading modes up here, there is the render passes, of course. We're going to the indirect versions of each of these. So we're going to start with the diffuse indirect. Now it should be black because we've set the bounces to 0 because this is the indirect lighting. And so if I just set this to 12, you can see now we're seeing the 12 bounces of diffuse lighting. So we basically just want to see of how much do we need of each of these bounces without having it so much that it takes long per pixel. Because for interiors and places that need a lot of indirect lighting, you'll need more bounces so it fills in and stays bright. But by turning the bounces down, you can reduce the likelihood of fireflies and things like that. I'm going to focus on just this little area. I'll turn it down to 1 just so you can see more obviously the difference. It is way darker. Look at that. So we want to have it be still pretty bright, but not significantly darker. It's like with 6, I can't really tell the difference. Hard to tell. This seems a little bit brighter, so I'm going to say maybe like 5. We'll stick with 5 for this one. Now I'm going to write this down to the side because if we go to the glossy direct next, glossy indirect, it's like, wait, I have the bounces set to 0, but this entire scene is filled. What's going on? So it's because, especially with principled shaders, it's giving off both diffuse and glossy. And so they kind of interact with each other a lot more than the other ones do. In this case, I'm going to turn it back off and just set the glossy, and then I'll add the 5 for diffuse back. So you can write down what the other one was. So this is 12, and so this is pretty good. Obviously, glossy is going to be far more speckled, and that's fine. So in this case, let's try with the 6. Yeah, I'm not seeing much of a difference here either. 3 or 4 is usually a good baseline for indirect lighting, at least. Usually 1 or 2 never feels quite enough. It feels still too dark. 3 or 4 tends to look the best in my opinion. So I'm going to stick with 4. And I'm going to add the 5 back. All right, transmission. Oh yeah, make sure I'll disable the compositor. And so for the transmission, you'll kind of see the effect of how each ray for every glass pane it hits, it takes another bounce to pass through it. You can kind of see it just by incrementing. So if I do this, you can see, we can see outside. We can just barely see the fire. I'll do this. Go in, we can barely see see the inside. We can start to see the background. And now we can finally see behind this big glass pane, right? Then we can add those. If you notice with this case, at least, the lamps for the stairs, they're showing through the glass because although the camera ray visibility is disabled, it's being shown through glass and that counts as transmission. So I'm going to turn that off. It shouldn't affect anything else. So I'm going to turn it off for the stairs. Now back to these. And transmission is usually where you want to go a little extra on the bounces just because it tends to give the glass a better look in general, so I'm going to make it 6. Just give it a little extra just in case. In this case, this scene does not have volume, and that's where, you can validate it just by doing that, of course. So now we're going to go to the, and then for the transparent, you can do whatever, but in this case, you'll notice that the fire It's not counting as transmission because it's just an alpha mask, and that's why we set the transparent separately. So do this, and it still has this little box glow. And so I'm going to do it one more, and that seems to fix it. I'll set it to 5 just to be safe. But yeah, so we have now our bounces. This previously was just set to 12 for all of them, which is perfectly fine, especially for an interior. You want those extra bounces. But if we go to the full combined result now, it's looking a little more consistent at least. And we saved some bounces. And now with the max bounces, this basically clamps each ray of how many bounces it can have. So of course, like if you're hitting only transmission, it'll stop at 6. But what if your ray is going from transmission, glossy, diffuse, it sums them together. And so you're trying to clamp of how far you want it to go. Now I want to make sure the glass and everything behind it has sufficient bounces. So I think 12 is actually probably fine here. So I'll keep it at 12. All right, next we're going into the sample count, noise threshold, and denoise. I'm going to turn off the overlays so that way it's a little bit clearer. What I want to do here is I want to see what the problematic areas are, which areas take the longest. Now I could just kind of compare and check, but there's now a new pass for that, and it is the sample count. Now we're in AGX color space, so this is going to come out as gray, but the white result means that everything is at the max sample count. Anything that's dark or near black means it hit the noise threshold and ended early. So in this case, the problematic areas looks like it's right here and the chair. So the choice is then of how many samples do you need to clear up an area. And so if we just want to go here, so I'm just going to focus on this, and I'm going to see of how many samples it gets to before it's done. It's at 300 still going, 0.05 is the noise threshold. And so you can see after about 1,000, it's just focusing on a couple, and then it finishes. So the goal here is that you want the noise threshold to be as high as possible so that most of the pixels and samples that are unproblematic get caught, but that the problematic areas still go the full max samples, right? So let's go to where this area is. If I have it go to 496 at 0.05, goes pretty far. Yeah, it goes about all the way. 496, even at 0.05, it's still utilizing it. So I think that's still an important number to have. Now, another thing to keep in mind is with smearing, because once I add denoising, it's going to start smearing a lot because it's just looking at the final result of the image and then trying to denoise it from there. The important thing with this is that the albedo, if I change it with normal, it can tend to reduce the smeariness. Obviously, we're still pretty low on samples, so maybe I'll just change it to like 1024. So that way it gets through the samples really quickly. But as you can see, it does smear. Keep that in mind that the denoising is going to smear some, and that's why it's good to always have a solid result even without denoising. Not that it has to be crystal clear, but that it at least should feel fairly consistent and that there's not like a huge amount of inconsistent speckles. And that's what the noise threshold is to help with. And again, with here, so it seems like most of it, this outer area clears up around 500. So the original render settings of 500 is actually pretty good. The idea with the 4096 though is that then it can spend all that extra time on the really noisy areas, and most of the areas that are cleared up are just skipped after that. If I do 1, for instance, you can see it stops around like 30 and that looks horrible. And you can see with the denoiser, it'll look horrible. You always have to keep that in mind of how the denoise looks on top of the noise threshold and things. You can't really adjust these independently for that reason. So I could do this. So it seems like the 4096 doesn't even get to 0.1, which isn't great, but so let me test with this again. Okay, so that ended around 1,000, but we probably want a little less. 0.05 to 0.01 is when you start getting into more crisp territory. For those that wonder, there is a 0 option for automatic setting. I looked up what it was, and it's literally just 1 over the number of samples. So if I did 1 over 64 samples, that's already 0.01. And then it does clamp it, so anything less than 0.001 just becomes 0.001. I think in most cases you can get away with something larger. So I'm going to go with the 0.05, 4096. and I'm going to denoise. And with the viewport, now that we've set that, you can just set this to whatever is sane for your hardware. So I'm doing 128 at the most with a 0.1, and you can denoise in the viewport if you want. Just know that it's obviously going to be a less quality denoise in the viewport, and that's why it'll look different. With that, we're going to render, and I'll compare with you the denoising from this and a compositor-based denoise. So to do the compositor denoising, we're going to go into the passes, we're going to enable denoising data, and then for the lights, we're going to check all of the passes that we need, or that we use. So diffuse, glossy, transmission, of course, don't have any volume, so we don't need that, but you may, and emission and environment. And for reference, if you right-click any of these properties and go to the online manual, so on this passes page, lower down, there's a combining tab, and this will actually show you the equation of how the combined or beauty pass is made. And so we will be actually using this as reference. I'm recording this after the render, but I should mention that another big tip for denoising is to simply render at a higher resolution and then downscale back. And the reason is that your denoiser is just working with the image. It's not working with the Blender scene, it's just the image. When you have a bigger image, there's more for the denoiser to work with, and that can result in more effective denoising. With that, let's render. While this is going, I'll actually talk about temporal denoising for a moment, because it's out of the scope of this video, but I want to make sure you get an understanding of it. Now, Blender technically has temporal denoising. It is the optics only implementation, and you can only find it if you search for it in the F3 menu. I did make an add-on that exposes these settings a little bit if you're interested. It's on my extensions repository. I'll link in the description. But if you don't have optics graphics cards, like an NVIDIA ray tracing graphics card, then you'll need a separate denoising solution. There are multiple Blender add-ons. I'll link some of the Blender related paid tools for that. There's also Adobe After Effects has temporal filtering, if you're still an Adobe fan, and DaVinci Resolve's paid version has temporal denoising. The free version doesn't, but the paid version, the studio version, does. I'm not affiliated or sponsored for any of these. It's beyond the scope of this video, but I figured I should at least mention it. Got our render. So this is the built-in denoise version. Honestly, it's not bad. For those interested, I am going to show the multipass version of this. So I have a preset asset of this. I will link it on my Ko-Fi and Patreon, but I will explain how it works as well. We just got this gigantic node group, and we just basically plug everything in. But let me just show you what it's doing. So if I do the viewer node up here and refresh it. So what it's doing is taking the direct lighting. So this is basically just the lighting, no shader color information per se, the indirect lighting, and the color, which is basically just the shader color. And then it goes into here, and I made a subgroup. So then I denoise the direct lighting. Just do that on the full settings. Same with the indirect. Added a toggle if you don't want to do the denoising for a specific set of lighting. And then we're following this diagram. So it's adding the direct and indirect together and multiplying that by the color. So that's what's happening here. So adding, multiply. And that's all you have to do is follow that diagram. So I want to make sure that you at least knew how to set it up on your own if you wanted to. And then if you wanted to just get the final product, you could just do that. We don't have any volume, so I'm just going to ignore that, turn it off. I'm going to add these. All right, so now I'm going to show you the comparison. So I'm going to focus on this area. Again, this is a low res render, so I didn't do the full res. I probably should just do that, but that's okay. Actually, I'm just going to go full res. You're already here. What else could I talk about? Oh yeah, Blender Conference. Blender Conference in North America. So Autotroph, which is the head company of CG Cookie and Superhive, they are making another conference. Instead of LA, they're doing it in Texas this year. So I am planning to be speaking at it. Honored to be among the first speakers chosen to kind of help market this, because I really enjoyed the LA one. I got to meet amazing people, and there was a lot I enjoyed coming out of it. Really hope if you're interested to purchase, you'll be able to get to see me as well as many others. Alrighty, with this denoising, even with the normal and albedo based denoising, it's still really smudgy. Look at that. And so if we go back to the multi-pass denoising, look at that. It brought back a lot of those details. Now, it is not perfect by any means. The answer to this, I would say, is probably even reducing the noise threshold further or even raising the max samples with it, but it does bring back a lot of these details. That's the nice thing with this multi-pass denoising, is that for areas that are especially heavy, tiny texture details, this can bring a lot of that back. So you can see, like, even especially like in this area, it preserves some of those details really well. The cons with this is, of course, it is denoising a lot more. With this, it's just a single image being denoised. In this case, it's 2 passes per of these, so 2, 4, and 6. So it's denoising 6 images instead of 1. So more processing power. In most cases, I would recommend this. You can try them pretty quickly just with a single image, and you can see how well that works. There we have it. We have our render. And that's it. That's my comprehensive overview on samples in Blender and how to make them more consistent. I hope you find that useful. If you're interested in more videos on optimization in Blender, then check out my full series here on YouTube. So thanks for watching. Happy sampling and happy blending.